We humans are a curious species. We constantly look at the world around us and ask, why? Why does the sun shine? Why do we feel love? Why does a tree grow towards the light? To answer these profound questions, we have developed two fundamental ways of looking at reality. One approach is to break things down into their smallest, most basic components. This is called reductionism. It's like taking a watch apart, piece by piece, to understand how the gears and springs make the hands turn. This view seeks to find the fundamental building blocks and the simple rules that govern them. The other approach is to step back and look at the entire system as one interconnected entity. This is called holism. Instead of dismantling the watch, a holist would observe it in action, its relationship with time, its purpose for the person wearing it, how its design creates a single functional object. Holism suggests some things can only be understood by looking at the whole picture. It focuses on relationships, patterns, emergent properties. To navigate this landscape of ideas, imagine a great ladder of explanation, often called the ladder of abstraction. Each rung represents a different level of complexity, a different scale at which we study the world. At the very bottom, the world of quantum physics, strange particles, and forces. As we climb up a rung, these particles combine to form atoms. The domain of chemistry, climb higher, atoms join to form molecules. Another step up, the complex biochemistry of cells, the foundation of life. From cells, we climb to tissues, then to organs, like the heart or the brain. These organs work together to form a complete organism, like a person or a tree. The reductionist approach has been one of the most powerful tools in the history of science. Its strength lies in its ability to isolate variables and establish clear cause and effect relationships. When you want to understand how something works, taking it apart is an incredibly effective strategy. If your car breaks down, you don't meditate on the carness of the vehicle. You want a mechanic to find the specific broken part, the faulty spark, plug the dead battery, and replace it. This is reductionism in action, and it is spectacularly successful for solving a certain class of problems. Think of modern medicine, the development of antibiotics, vaccines, and genetic therapies. Scientists didn't discover penicillin by considering the holistic wellness of a patient. Instead, they isolated a specific cause of illness, bacteria, and then found a specific substance that could kill it. Similarly, our ability to map the human genome is a monumental reductionist achievement. By breaking down our biological identity into a sequence of 4 chemical letters, we have unlocked profound insights into hereditary diseases and have begun to develop treatments that target the problem at its most fundamental level. The beauty of reductionism is its precision and predictive power. It allows us to build reliable models. While reductionism gives us the building blocks, holism gives us the blueprint. This perspective finds its power in understanding systems that are complex, dynamic, adaptive. It reminds us that in many cases, the whole is indeed greater than the sum of its parts. Consider an ant colony. You could study a single ant for its entire life, analyzing its anatomy and brain chemistry down to the last molecule. But you would never understand how the colony manages to build complex nests, wage wars, farm, fungi. These are collective behaviors that emerge from simple rules followed by thousands of individual ants. Holism excels in fields like ecology, where everything is connected to everything else. A holistic ecologist, studying a forest, doesn't just catalog the individual species of trees, animals. They study the entire system, the flow of energy from the sun to the plants, the cycle of nutrients through the soil, the predator-prey dynamics, the forest's response to drought or fire. They understand that removing a single key species, like a wolf beaver, can cause cascading effects that change the entire landscape in unpredictable ways. So, how do we decide when to be a reductionist and when to be a holist? The answer lies not in the inherent superiority of one view over the other, but in the nature of the question we are asking. The key is to match the tool to the task. Think of it like choosing a map for a journey. If you need to navigate the streets of London to find a specific address, a detailed street map is invaluable. A satellite image showing the weather patterns over all of Europe would be utterly useless for this task. The street map is your reductionist tool, precise, detailed, perfect for a specific problem. Conversely, if you are a pilot planning a flight from London to Rome, the street map is useless. You need the big picture. You need the weather map that shows you where the storm fronts are. You need the weather map that shows you the jet streams. This is your holistic tool, Trying to use the street map to plan the flight would be as foolish as using the weather map to find a coffee shop. The perceived conflict between reductionism and holism is ultimately a false choice. They are not opposing armies in a war for the truth. They are complementary tools in a single toolkit for understanding. The most profound insights often come from combining them. A reductionist discovers a gene associated with a disease. A holist then investigates environmental factors, diet, stress, that can switch that gene on or off. Together they create a much more powerful and complete explanation that can lead to more effective, personalized treatments for real people. The path to understanding isn't choosing a side, but learning to see parts and whole at once. Are we just the sum of our atoms? Or are we something more? A complex tapestry of thoughts, emotions, experiences. The debate between reductionism and holism shapes how we approach medicine, ecology, psychology, economics. The real question isn't which view is right, but what lens helps us find a meaningful answer. Ultimately, these two perspectives are like different camera lenses. A macro lens shows the intricate details on a butterfly's wing. A wide-angle lens captures the entire meadow, flowers, the wind, the sky. Both images tell a truth, but neither tells the whole story on its own. To truly understand our world, we must learn when to zoom in and when to pull back. Let's take a simple, wonderful example: water. At a low rung, we can describe a water molecule using reductionist chemistry. It is H2O, two hydrogen atoms bonded to one oxygen atom. This simple fact explains an enormous amount, like why ice floats or why water is such a good solvent. But to understand why a river flows in a particular direction, we need to climb the ladder to the level of physics and geography. We need to consider gravity, topography, and the volume of water. The properties of a single molecule are not enough to explain the behavior of a river. If we climb even higher, to the level of ecology, we ask different questions. How does this river system support a population of salmon? How does the presence of the salmon in turn affect the health of the forest by delivering marine nutrients inland? At this holistic level, we are studying the intricate web of relationships between the water, the fish, the trees. No single level of explanation is the correct one. The level you choose depends entirely on the question you are trying to answer. The latter isn't a hierarchy of importance, it's a menu of perspectives. However, this laser-like focus on the parts can also be a limitation. Reductionism can sometimes make us miss the forest for the trees. By breaking a system into its components, we risk losing sight of the very thing that makes the system what it is, the way those components interact. A single water molecule is not wet. A single neuron does not have consciousness.